Okay, so we have here that the function r of t represents the rate at which the water is flowing out of an inverted cone in cubic centimeters per second. Okay, that's really important. So what we're trying to do is we're trying to interpret the integral from 2 to 7 of capital R of t dt in this context. So it's important to write down the units. So if the units of capital R of t are cubic centimeters per second, then remember that what the integral will basically tell you is if this is the rate, if r is the rate, when you get the integral, this represents the quantity. And when you're talking about the quantity, you basically are looking at whatever the units are, it's going to be the numerator because that's the one that tells you the quantity. And so, the rate is simply the quantity divided by seconds. And you have to remember that the limits of integration, are values of whatever the independent variable is. So since here you're integrating with respect to t, those are going to represent t values. And so those 2 and 7, those represent seconds. Okay, so then the interpretation of this is going to be the integral from 2 to 7 of r of t dt represents the amount of water in cubic centimeters that, and then what are we talking about? Well, we're talking about water flowing out. So this is the amount of water that flows out of the cone. And then that's where you bring in the limits of integration. This is from 2 to 7 seconds. And so it's really important. The units are really important, and you get them from the original units that you had. Okay, so here we have the rate at which, the rate at which the frog population in Jumbo Island has been increasing since 2001 can be described by the function f of t, where t is in years. Interpret the integral from 0 to 9 of f of t, and this is missing, dt. Okay. Now, again, really important to write down the units. And so this function, this is the rate, and it says that t is in years. So since it's the rate at which the frog population is increasing, then this would be frogs per, and then since t is in years, this would be frogs per year. Okay, so then the interpretation of the integral from 0 to 9 of f of t dt, and again, remember, these are units of time, and in this case, it's years. And so, again, if f of t is the rate of change of the population, then the integral represents the amount of frogs that the population increased by. And then you integrate the time. So from year 0 to year 9, well, since it started in 2001, this would be from 2001 to 2010. And that's it. Okay, so it says that the figure below represents the power consumption, which is the rate of change of energy, of a little house in Long Island starting at midnight until 10 a.m. Find the total energy used during this period. Okay, so here this represents midnight. And over here this is 10 a.m. Okay, now since power is the rate of change of the energy, so power, let's just call that P of T, and then we want to find the total energy. So that's asking us for the quantity, the amount of energy. And so the energy is, since we know the rate, well, that's just going to be the integral of the power, right? Now, from where to where? Well, that's going to be from midnight to 10 a.m. So midnight, we call that 0, and then 10 a.m. is going to be 10. And so since this is what we're looking for, the integral from 0 to 10 of P of T dt, well, then that's basically means that we're looking for the area underneath the power curve, right? Okay, so then we just have to figure out how to break this up into little chunks so that we can find the area. We can turn this into, how about we find the area of this rectangle, which is going to be 20. And then we find, oh, let me change the color. Let's do this rectangle, which goes from 5 to 10, and then it has a height of 3, so that's going to be 15. And then last but not least, this little triangle here. So this little triangle goes from 2 to 5 and has a height of 3 as well. So this is 9/2 or 4.5. And so then this is just equal to 20 plus 15, that's 35, and then plus 4.5, that's 39.5. Now, what are the units? Well, it says that megawatts are the units. And so, megawatts. There we go. So, suppose V of t is the velocity of a ball thrown right towards your face by your brother. That is not nice. Let's say it's a Nerf ball because, you know, we want to stay family friendly here. But then after 5 seconds, the velocity of the ball becomes 0. Interpret the integral from 0 to 5 of V of t. This one's also missing the dt. Sorry about that. In this context. Okay, so what it's saying is that your brother threw a ball at your face, and then after 5 seconds, the velocity of the ball becomes 0. Interesting. Well, if the velocity of the ball becomes 0 after 5 seconds, so got a little picture here. Doot, doot. And then, okay, so this, let's say you, and this is your brother. So the ball goes whoop, 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 splat. And then what happens to the ball? Well, then it comes down, right? And then lands right there. So the integral from 0 to 5 of V of t represents, since this is it's telling you that the velocity of the ball becomes 0. Well, when it hits you, the velocity isn't really quite 0 yet, and then it has to come down here and fall, and then it goes with some velocity there, and then it stops, right? So then what this represents, since V of t is the velocity, well, then this is the distance from your brother to your face plus the ground, right? Pretty much around. So basically, you know, the ball goes right here this much distance, and then comes down here this much distance, and then the velocity becomes 0. And so that's what that integral measures.